Hi everybody. Thanks for being here with us. My name is Carolina Riekstin. I am Brazilian. I moved to Montreal in 2016, and I am currently a software developer at Bell.
Hi everybody. I'm happy to be here to present you the talk of today. My name is Myriam, and I live near Lévis, near Quebec City. I work as a software developer for Elapse technology, but I am also a teaching assistant at Université Laval, where I teach about software development, architecture, clean code, and also test. Okay, so let's start with that nice quote. Tests are stories we tell the next generation of programmers on a project. So for us, tests are more than just tests. And today we're gonna dive into the subject.
All right. So briefly here, that's the contents for the presentation today. So we start with what is unit test? Why do we do that? What to test? How to test? Then we are going to see a demonstration, and we have a conclusion about other types of tests and some references for you to check later.
Okay, let's start with the first part. So what is unit testing? In this part, we will talk about unit, scope, and we will do a quick overview on classification of tests, so we can understand a little bit better the word of test in general. So what's a unit? A unit is the smallest testable part of any software. A unit, it might change from one person to another. If you're in OOP, it's probably a class or its method. But if you're in functional programming, it's going to be a function. So what is unit testing? It's testing a little smart part of the code in isolation. We take a small portion of the code and test if that piece really does what it's supposed to do, according to the contract we intended. I like the definition of unit test by Martin Fowler, who is a well-known figure in software development. He says, the common property of unit test is small scope, it's done by the programmer herself, and it's fast. So you can run them really frequently while you're programming. Let's continue with the scope. Here, we have something we call the test pyramid, because it's usually the form that we want to achieve with our testing infrastructure. In here, it's not about the type of test, it's more about the scope, which is small, medium, or large. If you can see here, the higher we are in the pyramid, the more integration between components is involved in our test. So they tend to be slower tests. For example, if you are booting an application and then doing a call from the UI to the DB using a real DB, it's probably a large test. Maybe you heard about tests that run during the night because they're long to run at your workplace. They're probably medium to large tests. If we continue, the lower we are in the pyramid, the more isolation. It means that your test is limited in terms of scope, and instead of using a real DB infrastructure, like we just said, it will probably tend to mock or stub component like the DB, or even mock or stub component that is collaborating with the class under test. By their nature, we just talked about, the unit tests are considered small. You can see here, I have percentages. Percentages here are just approximation, but the proportion are still valid. Large tests tends to validate the API path if something is working correctly at large, but they cannot give you real details about what went wrong if they fail. So smaller tests can help you pinpoint a little bit better those problems, because when you do smaller tests, you reduce the scope of everything that is involved. And tests tends to run faster, so you can use them and run them frequently when you are programming something. Even though there is different type of tests, every scope of tests has their purpose and their value. So we just need to use them with balance. If your software already has an existing testing architecture in place, just be aware of the current shape of it. Here I have two examples of other shapes that we see. The first one is the ice cream cone. You see in that case is the reverse of the test pyramid. So you have a lot of end-to-end tests, like the large one I was talking about, and probably in that code, when you change something, it's tricky to update or modify the code without breaking those large tests. The second example I have is the Hourglass. So you have a pretty similar problem related to large tests, but you still have your smaller tests. The problem here is the medium tests, which are probably integration tests. And those tests, they're meant to test the glue between the little units and the other part of the system, which can be useful to test integration and collaboration between the different parts of the system. To continue, I present you the test quadrant. In here is more about the type of test. Just be aware that those tests are classified by their reason to exist and also their reason to fail. We have 4 aspects in here. Let's start with the first one, which is guides development. This one is meant to help us developers and creators to verify if what we are doing is the right thing while developing the product. Second one here is critiques the products. It's meant to verify if the products really answer the expectation of people. For example, do people like it? Or the performance is good enough? The next one is the business. So it refers to the product itself. And finally, we have technology, which are the details of implementation or performances. You see, I added a lot of different type of tests, but I'm not going to cover all those type of tests. That subject is probably big enough for another whole talk. You will see that the unit tests are in Q1. So they drive the development. They're meant to improve the design under the functionality. So it means better code, better architecture, a product that is more entitled to evolve easily with the future requirement of the product.
All right, so let's talk a little bit about why unit testing. So one of the most evident benefits of unit testing is that they are documentation. There you can find what every piece is expected to do, what is the expected behavior in case of a failure or an edge case. And as such, you can also use them when doing a code review for a colleague. For example, I usually do that when there is a code review to do. I go to the tests to understand what that code should be doing, and then I go back to the code itself to do my review. And as you see during the demo, the feedback of a unit test is super fast, as we stop as soon as a small problem is detected. And the sooner you find and fix bugs, the cheaper to fix it. It's like in manufacturing. So when you're doing a car, if you detect any small problem right at the beginning, it's much cheaper to fix that problem than if you have to fix like the whole car or something, or do a recall later in the process. Unit tests also support refactoring. So for example, if you need to change a part of the code and you have good unit tests for it, you'll be able to check right away if your change broke something. We are going to see that in the demo as well. I'm going to show you a refactoring and how the unit tests, when they are covering everything you need, they can give you that confidence that you are doing a good job. Right, unit tests is also a way to have a cleaner code. So the process of thinking twice to write the test and the code will naturally show you better ways of coding, and may also point you in the necessary improvements in the architecture. For example, you notice a test is hard to do or that needs a lot of setup. These are signs you need to change something on your code. And last but not least, tests are also a good way to explore your code base. So suppose you start a new job and the team needs to better test some parts of the code. If you take the task of writing the tests, you will see how they will quickly bring you to the game. I've done that a couple of times. It really helps. And a normal question is, what to test then? So when it comes to what to test, we normally think about the contracts and the expected behaviors that piece of code you are writing has. So what is this unit expected to do? Is it important to check? What the other parts that consume it expect from it? Some other questions that might be helpful when defining what to test are you testing something the unit should be doing? Are you documenting it, or there is a design issue to fix? So it's when you have, for example, a function in front of you and you are checking what to test, and the unit test seems too complicated, for example, maybe the code needs some refactoring. So maybe there is a design issue to fix, because tests are somehow a mirror of the architecture. So a complicated test can mean a complicated code. So that's some of the questions you have to have in mind when you are defining what to test. And if you answer that questions and you know more or less what you want to test, you go ahead and you write some common cases and some edge cases. Another easy case to answer what to test is when a bug is found. So you write a test to catch it, then you fix the code and run the test again. And if you think about what not to test, we normally say so for functions that are trivial or that need their real interactions with some other systems tested. So then you'd go for another type of test and not a unit test. Let's see here a brief example of one example of what to test and another example of what not to test. So on the left, we have a system that is supposed to answer which greeting you use when you're saying goodbye before 10 a.m., before 20 p.m., for 8 p.m., or later. So you would like to make sure that depending on the time, you are having the good answer. So good morning, good day, or good evening. On the right, we have an example of a get and a set. And for example, this get is just returning the name. So you don't have actually a lot to test. So we will probably test other parts of the code and not this specific one.
Now that we understand a little bit better the unit test theory, let's talk about the more practical stuff. So here we have convention and tips for you. The first one, we just talk about this. Remember that your unit test should always test one thing and should have only one reason to fail. The next one is here. Choose a name convention for your test. Here we gave you the given when then convention, but there is other convention that might apply to you. It helps to quickly identify the test cases. Don't forget to write your test name in terms of behaviors. So if you add an expert in the field just beside you, you should be able to understand the test by only reading the name. The next one is to use meaningful names. Don't be afraid of using detailed long name as variables or for your test name. The more clarity here is the key. You should be able to quickly read the test, and you should not need to run or debug the code in your head. Finally, the next tip we are giving you is to use refactoring. Use refactoring to write clean tests. You know, unit tests and other tests are part of the code, so they deserve to be refactored too. You can create method to prepare setup, avoid redundant code. You can create test helper classes to add some complexity. Sometimes setups are technically a little bit complex, so you can add complexity there. And you can make some assertion more clearer using that. And finally, use constant to have magic values in your test. It's going to help for the context of the test because you will be able to name those variables. During this presentation, we talk about mock without really giving you a definition of it. So now we will explain you what's a mock and what are the 3 main reasons to use them. First of all, to test something as a unit, a key element is isolation. And to achieve isolation, one of the best tools is mocking. And remember, in here, we mock objects that contain behaviors. So let's take an example. Here we have the class A, which is the class under test. And A depends on B, probably calls one of B's methods. To achieve a good isolation of A, we need to replace the instance of B by a mock to cut the dependency that we have on B. You will see, if you go check in the dictionary, you will see that mock means to imitate or mimic. Here, what we want is pretty much similar to that. We want to use a dummy B, so we can cut the direct dependency to B. And you know, B is a mock, so it simulates the behaviors of a real object, so you don't have to rely on the real dependency. Imagine that B was a dependency like a client to an external service or an external API. So mocking B, in that case, will remove the risk of unexpected error related to a connection, a latency, or any changes while doing the test. So it helps the test stability. The second usage for mocks is to pilot the test. Because mocks can simulate behavior, we can set them up as we wish, depending on the contract of the mock object. So here, we still have our class A. And you see that the class A depends on B, using its method is available. With a mock, we can manipulate B to return the 2 possible answers, so true or false. So we can test every cases of A depending on what B returns. In that case, based on B response, we want to return, for example, a message or to raise an exception. So mocks can help us doing that very easily. And also here you see that we have an example of a test name with the given when then convention. Finally, the third reason to use a mock. You can use a mock to verify the collaboration between A and B. Here, I just wrote a little piece of code so you can understand a little bit better the value of using a mock to verify. Imagine that in that case, B was a DB connection. Without mocks, maybe you would tend to use a real DB, insert the user, and then get it back to verify that the insertion already happened as a test. With a mock, in the context of a unit test, you can only verify that A called B with the right parameter. Mocking frameworks usually provides a verify method to do this. So you don't have to use a real DB, and you can just check if A really called B insert with the right user in parameter. So in conclusion, mocking is a great tool to add to your testing arsenal, but be aware, too much is like not enough sometimes. So don't forget to only mock objects with behaviors.
So it's demo time now that we understand the unit test theory. Let's talk about more practical stuff. But before, just to briefly prepare you for the demo, here's what we'll be using today to show the unit tests in action. So we are going to be using PyTest, as you figured, and we are going to also going to show you the Parameterize. That's a way to run the same test a couple times with similar but still different cases. We are going to use raises for when we want to make sure an exception is raised. I will show you how it's possible to use Python assert to check the results, but also Grappa, a different library, and should from Grappa. And we'll also be seeing mocks, how to build a dummy object with mock and return value, how to patch and raise a controlled exception with side effect, and a monkey patch to replace a function call by something we want to do the tests in isolation. We have some references for all these topics at the end in case you want to check more the theory behind each one of them. And another important comment is that the way we will show you the test is not the only way to do them. And sometimes some options are preferable, but sometimes it's a matter of opinion what to choose to use. Okay, so let's see. All right, so it's demo time. I removed my video so that we have more space here to see the code. So here on the left, I'm going to be writing the code for this exercise, and on the right we have our tests. I have some setup already done here to save us some time, and let's go. So the exercise we brought for you today is from the codewars.com website. It's a code kata, and the idea is to write a function take umbrella that is going to tell you if you need an umbrella to go outside of your home on that day. So the rules are: if it's rainy, you take an umbrella. If it's cloudy and the chance of rain is over 0.20, you also take an umbrella. And similarly, if it's sunny, but the chances of rain are bigger than 50% during the day. Otherwise, you don't have to take an umbrella. So the options for the weather are sunny, cloudy, and rainy. And the rain chance is valued between 0 and 1. So let's start. So first thing here, I'm going to write take umbrella with nothing inside. And I'm going to write a test that will fail. And then I'm going to go there and write the function that I need for the test to succeed. So let's go. So the first test is I'm going to take an umbrella given rainy and return true. So for this first case, I'm going to be using assert, but we have other formats I'm going to show you on the next test. So I'm going to assert that take umbrella when it's rainy, doesn't matter the value. It's probably going to be 1, right? Actually, here is not 0, but put 1. I put the constants here to make it easier to understand the test. As you remember, tests are documentation. So if someone is coming here, I want this person to understand that if it's rainy, it doesn't matter the value. I'm going to return true always. So I'm going to come here and I'm going to run the test, and you see it failed because right now I'm not returning true here, and on the test I am expecting a return true. So I'm going to say here, if weather is rainy, I return true. That's simple. Let's run again the tests, and voila, we have our first test passing. So I'm going to continue here and go for the next example. So in that case, I'm going to say that I need to take an umbrella when it's cloudy and when the chance is over 20. So I'm also returning true for that case. And here, just to show you another way of doing assertions, we can use Grappa. So from Grappa, I'm going to import should, and that's how we write it. I call take umbrella, even it's cloudy, and the value is over 20. So similar to this one, I defined some constants for the other cases. And in that case, the return should be true, right? So I'm going to go ahead and run it. And we have a failure. And here we can see why. We were expecting a value that is true, but we got instead a none, because I have not implemented yet the cloudy case. So I'm going to come here and I'm going to say if weather is cloudy and rain chance bigger than 0.20, then I'm also returning true. And we have a success. The third case, in which I also will be taking an umbrella with me, is given it's sunny when the chance is over 50, I'm also returning true. So I'm gonna come here, copy the line, and I'm gonna replace that for the sunny one, and now the value should be over 50, and I also expect true as the answer. Nope, not yet, because it's none. So I'm coming here. I'm gonna go ahead and say, okay, if it's sunny and the rain chance is bigger than 50, I'm also returning true. Don't worry about this if here. We're gonna refactor that code in a minute. So run again, and voila, we have a success. Okay, so what happens then if I say, given it's sunny and chance under 50, I'm going to go ahead and return false, right? So I'm going to copy the line. I'm going to put here, and the value now is under 50. In that case, it should be false. Let's try. We failed because, again, we were expecting something. We were expecting false, and we got none. Why? Because here we didn't implement the last case, the return false. So I'm going to put here, return false. And all green. I want to add another case that is when it's cloudy. I'm going to here, given cloudy, and the chance is under 20, right? Now it's 20. I should also return false. That case is already implemented, right? So we have 5 green cases. But I would like to validate the inputs here. So I would like to do some sort of assertions to check if the weather is rainy, cloudy, and sunny only. So I'm coming here and I'm going to say, I want take umbrella given invalid weather. Then I wanted to raise an exception. And to raise an exception, I'm going to use by test raises an assertion error when I call take umbrella. Okay, but here I want to use something wrong, so I'll say wrong weather, and the value, again, doesn't matter. I'm going to go ahead and run. I failed because I didn't raise anything, right? So just to make it faster here, so I'm going to say I want the weather to be included in rainy, cloudy, or sunny. Otherwise, I'm going to say the weather is invalid. Let's see. Voila. We have the assertion here. I could do the same thing to validate, for example, the range for the range chance, right? But the test would be more or less the same here. So I'll let that for you to check later. So if you remember, we got this exercise from Code Wars, and at the end of the exercise, they put as an additional challenge, we should consider solving that using only logical operators instead of all these ifs and elses. So that's a good case for refactoring, right? So now I have my tests that are gonna help me when I change my code. They're gonna tell me if everything was working as expected, was working as they were before. So I'm gonna go ahead and change here to do like return if the weather is rainy is a true, right? So equal true, or in the case of the rain chains being bigger than 0.20 and the weather cloudy, I'm also going to return true, right? In the last case, the rain chains bigger than 0.50 and the weather sunny, right? So I covered all the cases here. Let's see if my tests are still good. And they're all good. So I did the refactor, I ran all my tests again, and I know that I didn't break anything considering the test cases I wrote beforehand. All right, so let's come here as we refactor the code. Let's consider refactoring the tests. PyTest has something that's really nice that's called Parameterize. And it allows you, for example, for these cases here that are not exception cases, they are checking the weather and the rain chance. You can give a list to just one function and it's going to run like 5 times. So I'm going to go ahead and write here, take umbrella, given a weather and chance, then decide. All right. And that's how it works. You write pytest.mark.parameterize, and then you say you are going to pass weather, rain chance, and an expected decision has to be checked. And here you put all your test cases. So if you see here on line 15, I had the rainy case, the chance any, and the expected return true. Second case was cloudy, chance value over 20, also true. Third case, I had sunny, value over 50, true as well. Or I had sunny with a value under 50, it should turn false. And the last one, cloudy, value under 20, should return false. Now I have to come to my function and say I have a parameter that's called weather, another one that's called rain chance, and another one that's called expected decision. And I'm gonna call take umbrella, with the weather that I have here, the rain chance. And here I will be using should be equal to, because I have an expected decision to pass. And that's it. Let's run now PyTest with minus VV so that you see the cases. You see, we have the 5 tests we wrote before. We can actually go ahead and delete them. And here we have the cases we just wrote using Parameterize. So I have the function name, and then I have the case. It's rainy, the value, and then it's true, the expected decision. So instead of writing all these lines, I have just these ones. Pretty nice, eh? All right, there's one thing more I would like to show you here. That is for the case where we have, for example, an API answering the weather. So instead of reading as a parameter, I'm going to go ahead and do a get on an API. All right, so we are back. I just stopped it here for a second to set up my API server. Let me hide myself here. So I have a fake server using Flask locally. It just answers randomly a weather and a rain chance. And here is the function we pasted before, just to save us some time. So the principle is the same. So I have the return here exactly as we did before. But now, instead of having inputs, I'm gonna go ahead and do a get on my API, and I'm gonna process the response, weather, rain chance, and then I'm gonna return. So if I come here to the tests and I just call that function without mocking anything, let's see what happens. Oh, first of all, I just import requests here. Let's go. You see, we have a get on the API. And as Myriam mentioned, when we are unit testing, we want our tests done in isolation. I don't want to do any kind of get on an API or any kind of get on a database or a post or whatever. So I want to make sure that I'm testing only the logic on my function and not the get to the API, right? So for this case, we are going to use a mock. So I'm going to go ahead and paste here for you. So I'm using mock that is imported here from unittest.mock. And I'm saying that whenever this thing is called, I'm going to return a value that in this case, since I'm testing, it's rainy and the rain chance doesn't matter, as I mentioned before, I'm going to return that value. And I'm going to mock the response from the API using that mock because I need the status code to 100 and the JSON to be that value. And for that, I'm going to use what we call monkey patch. We can also patch using only the patch as we have here. It's also a matter of option. In this case, I'm using monkey patch to tell whenever I see a request.get, I'm going to return the mock response. So I'm not going to actually do the get to the API. So let's try that again. You see here, let me hit and enter so that you can follow. I'm going to run again. No gets on the API. See here? No movement. So that's what we want. So we have complete control of what we expect from each piece. So we do that completely isolated from any kind of infrastructure. As we did for the parameterize, we can also set up this part here in a function. So I'm going to go ahead and show you one example. So on the top here, I'm going to add a mock weather API that is taking a weather and a rain change, and it's returning all that setup with mocks for me so that I don't have to repeat that on every function. And here, even better, I'm going to use Parameterize for all these good cases, not the exception ones. So as an example, same thing as we did before, but right now I'm using my mock weather API and I'm using monkey patch to tell the function whenever we have request.get, I'm going to return the mocked response and I'm not touching my API. So let's go ahead and see, we have our tests. These are the last ones we added and no hit on our API. And just to conclude here, one thing is also good to test in this case is the exception, because I want to make sure I take an umbrella if I don't know what's going on. If my service is not working, yeah, just take an umbrella. It's better. So for this case, I'm going to show you how to use patch. So I'm going to say take umbrella with API given an exception reading the weather, then I'm going to return true. And for that, as we did for the PyTest raises here, I'm going to use with patch request.get. But in that case, I'm going to say I have a side effect. That's one way we could use to raise exceptions in a controllable way. So I'm going to say that something went wrong whenever I have the request.get. And then I'm going to take umbrella with API, and that should return true. If I want it to raise an exception to some other part of my code, I could just add here the pytest.raises. So I put a comma here at the end, and then I patch, and then I assure that it's raising something. But in this case, I'm not raising. I'm just saying, okay, I'm going to take an umbrella. So let's run that. Voila. We have tested the exception as well. So I hope you appreciate the demo. So let's jump to the conclusion. Here we brought just two examples for you to see other languages, unit tests in other languages. So in Java, we use the test annotation to identify a test. So here we have a simple example we brought from this web page. And here on the right, there is a test that I wrote myself, is in Go. And that's more or less the shape we usually see in Go. So we have the setup, we have the tests and the assertions at the end, as we showed for Python. And another thing that is nice in Go is that we have what we call table-driven tests. So we have a set of tests here that are similar to the Parameterize that we showed in Python.
We also added some references for you. Depending on the language you're working with, you can also check for books that are in that list. We have good references here in Java with the Growing Object-Oriented Software book. Even though it's not your language, when it's about book, you can read them in ideas gonna be applied to your context usually. And if you want some practical tips on how to attack refactoring of your code, go check for the Working Effectively with Legacy Code. You will see that tests are a real tool to do this in that case. And finally, I hope today you learned good things about testing. If you're interested in continuing your learning, we have other subjects that might interest you here. So don't forget to be curious, and we hope that we gave you the tools to build that confidence, that courage to start doing your test or just polishing the one you already have. Yeah, so thank you.
Yeah, thanks for being with us. And now we can answer some questions.
Yeah.